I'm Pingping. I'm a PhD student of Professor Stavros. And today I'm very excited to listen different perspectives from the CCS, CCU, different technology or supply chain perspective. And now I will share a very broad picture what I'm doing for the system optimization for the CCS, CCU superstructure system design. At the beginning, I want to share a very new figure is published in this month. It's kind of from the scientific perspective. We already late. We already past almost already past the 1.5 target line. So all the evidence show us we already late. And then folks, what we are doing, still there exists a huge gap between the project announcements and the net zero target for 2013. And folks in Europe, the gap also exists between the capture demand and the available storage. It's more than 40%. The storage still need to fill the gap of the capture project announcement. But I also don't want to overdress the role of the CCS CCU. Today, a lot of people already say very clearly. But for the hard to abate these sectors, we need to combine all the potential technologies, not only the CCS CCU. Firstly, we need to further improve the energy and processing efficiency, and also combine other hydrogen or fuel switching or electrification to deeply reduce the emissions. And then some avoidable emissions that are hardly to remove or decline. We have to consider the CCS CCU. And not only the CCS CCU, because we're also ambitious. We want to achieve carbon negative. So we also need to combine the CDR, the carbon dioxide removal technology, to help us achieve or get closer to the target. Okay, let's focus on the CCS CCU systems. Today, a lot of people already talk about specific units of the system, but actually most of the time, the people just focus on the foreground system, capture, condition, transport, storage, utilization, this main process and units. But the broad picture behind the foreground system, the background system, also very important, especially in nowadays, the transiting and changing society. The dynamic changes inside the system, in the background and both the foreground system is very important, especially involve the technologies transformations, so should not be neglected. We will do the system and analyze. What that means specifically for the CCS CCU systems? Actually, today already, some people already mentioned, for example, the changes in background systems, the different electricity mix or the heat supply will directly affect the evaluation of the foreground technologies, the environment performance, technology performance, and the investment and the government political subsidies, and including some key policies, for example, the inflation reduction actions in United States will directly affect the speed of technology scaling up. And the speed of technology scaling up and also the expansion of starting up companies will directly affect the cost reduction projections. So it's hard to project the optimal technologies in different time for different countries because all the uncertainties during the development of technologies. Besides, there also exist a lot of the competitions of other decarbonation technologies. For example, some breakthrough of the construction materials or chemicals. It also will change the market demand of specific low carbon technologies. And from the infrastructure perspective, there are also a lot of uncertainties related with the cross-border transport and the storage sites for inland or different countries' choices. So all these issues, what I mentioned, is kind of involve a lot of the different perspectives and stakeholders to participate the transitions, especially for CCS, CCU, this type of technologies, because it's talk about changes. We want to convince the people to integrate this new type of technology into existing infrastructures is really hard. So for such complex systems, we need a forward-looking perspective and systematic thinking, modeling optimization from the whole system perspective. So we build a comprehensive methodology framework for such complex systems. Firstly, we need to define the system boundary. We need to classify the foreground and the background systems. For the foreground system, we need to build a superstructure networks for different options along the supply chains. For the background system, we need to consider different energy supplies, and policy support is related with storage site choices, and also the different carbon tax and market demand for CO2-based products. Secondly, we need to input all the considerations in a consistent scenario development. Besides, we need to consider the technological constraints and also the realistic constraints in the systems. It's related with the transport networks and also the specific technology performance constraints. And then it's mainly about data processing work. We need to combine all the technology, economic data, and also the LCA, the data, plus some projections for the future about the projected cost, about the prospective LCA analysis, and input all the data to our mathematical optimization model. Want to find out the minimal system cost and maximum profit, especially if we involve the CCU in the systems. We need to consider some benefits for the systems, and then find out the trade-off between different targets. Of course, there exists a lot of uncertainties in the systems, so we need to apply some specific uncertainty analysis for the optimization model. For example, the Monte Carlo or stochastic optimization model. I will give a specific example. For example, for cement industry, today a lot of people already mentioned. For cement industry, from this picture, you can see the overall the superstructure for these systems. Firstly, it's about CO2 resources. We need to think about how to define the hard to abate for cement, because firstly, they have some potential to further reduce, combine the, for example, increase the biogenetic fuels, the clinker to cement ratio, and also the energy efficiencies. So there has huge potential to further reduce the cement emissions. So the CO2 resources is dynamics. And then we need to build the superstructure for the foreground system to consider multi CO2 capture technologies, different TRL levels, and also consider different transportation mode. And for the CCS, CCU, I consider one is in North Sea because most of the projects are announced in North Sea in Europe. And also you need to consider some potential democratic storage sites in Austria, for example. And for the CCU, I consider just two more mature, more promising technology. One is the CO2 heterotrophic fuels. The other is CO2 carbonation mineral materials. And from this map, you can see more clearly the distribution of cement plants in Austria. There are 9 cement plants. And I consider also 2 potential utilization plants. One is nearby Vienna, the other nearby Linz, and also 2 potential theoretical, the Austria storage sites. And also consider 5 potential, the North Sea offshore storage sites based on the announcement and the projections of the CO2 storage in North Sea. We want to use our modeling to figure out what the optimal decisions for this system. Should we build the pipeline for the CO2 transport? Should we transport CO2 only for storage, or some of CO2 could be utilized to get more benefits? Or should we allow the CO2 storage in Austria, or all the CO2 we just transport to North Sea? And then mainly about some data processing work, and then put all the data in the mathematical model to minimize the total system cost. And meantime, if you integrate the CCU in the city, we need to think about the total system profits. And meantime, I also want to find the trade-off between the environmental impact and the economic cost. For let the system result looks more clearly, we also introduce some KPIs, the levelized carbon avoided and levelized carbon stored, and also the system efficiencies in the analyze. So I just show very simple results from one case study. For example, if we only consider case study one, if we only consider the CO2 storage in offshore storage site for Austria, how it looks like. The storage distribution looks like very decentralized in different offshore storage sites. Based on the current project announcement, the Netherlands and Denmark and the UK are more attractive for inland country to consider for the store the CO2s. And if we consider for the case study two, if we consider both inland storage and offshore, so if the CO2 storage not buy in Austria, we also can directly store the CO2 in Austria. The big difference is you can see the cost will lower a lot, of course, because the transportation cost and also the storage cost lower a lot. And also, but some of the CO2 still need to transport to the offshore, for example, for Netherlands, to fill the gap because the capacity limited. And also the vary, you can from the figures, the transportation costs actually vary a lot from different scenarios or different case studies because we consider multi transportation modes. For example, just give example, if we, for the transport networks, I divided 3 areas. One is inside Austria, the other is cross-border. The third one is offshore, because 3 different, maybe involve different stakeholders to consider different transportation modes. If we are conservative scenarios, if the pipeline infrastructure not ready, we can use the existing truck or train to transport CO2s inside the country. And cross-border from inland country to offshore, maybe can directly use the ship and the train, lower the system costs. For the offshore, it depends on the capacity of the CO2 transport. So the shipping and the pipeline will be different. So if you transport more larger amount of CO2, of course, the pipeline will lower the overall the cost. But no matter which kind of the mode, actually from the optimistic scenarios, if the pipeline infrastructure not ready for Europe, we use other existing infrastructures, the overall efficiency, system efficiency can higher 80%. It means what we store in the storage site, 80% are avoided. So if you do some actions, better than do nothing. And also, we analyze the different multi-objective between the economic and environment, the trade-offs. It depends the decision makers, how much you want to invest for the investment. So you need to find the balance between these different objectives. Because the time limitation, I just briefly share one case study from the CCS case studies. And honestly, the system optimization for the carbon networks is really interesting, but also challenging. Because from the different level, from equipment process, and then the state, country, and region, even global, different thinking, it will give you a totally different view. And not only about this greenhouse gases issues, but these greenhouse issues will push us to think about this society and industry in another way, more deep, to think about which way is really better for our future. Maybe a lot of things we got used to currently, a lot of thinking or concepts, but maybe not good for futures. Thanks for your listening.